17, Maxwell's equations and the speed of light. They have found four basic properties of electromagnetism. And first of all, this one is Gauss' law. And Gauss' law represents by the way epsilon zero is missing in here. If I make use of SI units, why we need epsilon zero in this. So page 1, rho should be rho over epsilon zero. Okay, and this corresponds to the Coulomb's law, electric field flux. This is a surface vector integrated over a closed surface is a charge enclosed by that surface over epsilon zero. And this one can be converted into volume integral by making use of the divergence theorem over a volume that is enclosed by that surface, and this volume integral is this charge. So charge is the volume integral of density. So from this equation, divergence E subtracted by the density divided by epsilon zero integrated over for any volume should be zero. If I shrink this volume into very tiny one, this volume is a very small. However, it is non-zero, and in a very small range, this integrand becomes a constant. We can factor this out, and we can divide this non-vanishing volume out, and then we find the differential form of the Gauss law. In the case of a magnetic field, magnetic charge consists of North Pole and South Pole. No one can break this one into isolated North Pole and South Pole. Impossible, because they survive, always stick together. The sum of magnetic charge is always zero. So rho for the electric field is replaced with zero for the magnetic field. Magnetic charge always appears as a pair. They cancel each other, so it is zero. There are two divergence expressions. So these are called the Gauss law for the electric field and magnetic field. Next, we have the induction. Induced electric field is generated around a surface if there is a magnetic field flux passing through this surface changes depending on time. Magnetic field flux changing depending on time, then we would have electric field integrated over a closed path C. This is E, is like that. And this one, this is magnetic flux. So we have a time derivative integrated over a surface. So magnetic field scalar product with the area vector. We can always convert this closed path line integral into a curved scalar product with the surface element over S, whose boundary is the closed path C. Using this identity, we can combine this surface integral into curl of E plus, I moved this term, so negative sign becomes a positive, and I inserted this total time derivative inside the surface integral, then this position is frozen to be fixed at a certain time. So we need to convert this one into a partial time derivative. And the surface integral over an arbitrary surface always vanishes. I can shrink this surface into a very, very tiny surface. Then the integrand is frozen. I can factor this out of the integral, but the surface is still, even though it is very small, it is not zero. So therefore, we can obtain the integrand must be zero at that point. Therefore, we obtain the differential form of the Faraday's law. And Faraday, due to Faraday, we are able to generate the electric field. So most of our electricity comes from this Faraday's law. And again, there is a current, then magnetic field rotates around the current. That is called Ampere's law. So mu 0 I enclosed by this closed path is the same as the line integral over a closed path of the magnetic field. This is called the Ampere's law. Again, we can make use of Stokes' theorem to express this one as a surface integral over surface, and then this current I can be expressed as a surface integral with the current density. And then we combine together. Finally, we end up with the equation. The curl of the magnetic field rotates. Curl of the magnetic field is the mu 0 permeability constant multiplied by charge density. No charge density, current density. By the way, there is a symmetry of changing magnetic field generates the electric field, and the changing electric field also generates the magnetic field. This symmetry is called the dual symmetry of electromagnetism, and it was found by Maxwell. So we call this term Maxwell's law, and the complete theory is expressed as a Maxwell-Ampere's law. Okay, so this is a current understanding of the electromagnetic interaction under classical electromagnetism. So this is the equation of motion that looks absolutely different from F equals ma. For simplicity, we turn off any charged particle. So we erase the charge distribution, erase any current distribution. In that case, the four equation becomes very, very compact, and there is some difference between these two, but we find is absolutely the symmetric form, except that we can count the dimensions of electric field and magnetic field. We have all the length dimensions, this derivative 1 over length. Here, this time. It's not good. Any expression should be written in a same dimensional form. So the starting point of the electric field and starting point of the magnetic field were different, but finally Maxwell found that they are correlated. So we have to correct the wrong convention of the electric field and magnetic field. So what would like to do is multiply conversion factor 1, that is C divided by C. Multiplying this one, I can combine this one and this one. So this and this, C times dt becomes the same dimensions. So we find that electric field and the magnetic field multiplied by the speed of light, they are comparable and they are of the same physical dimensions. This is true because of this relation, and we end up with this. So why don't we compute this? What's that? This is Maxwell's law. We have multiplied C in here. Then I also have to multiply C there. Let's see. We copy. Curl B equals a mu 0 epsilon 0. I multiply C here, then C must appear here. I want to make this one and this one dimension the same. In that case, I need to multiply C in the denominator. So I had to multiply C in the numerator too. Therefore, this guy, C, dt, this guy, they have the same dimension. C, B, and E, they have the same dimension. We find that mu 0 epsilon 0 multiplied by C squared, this should be dimensionless. Dimensionless. We expect that mu 0 epsilon 0 has the same 1 over C squared, has the same dimension. Then when Maxwell constructed these four equations, the numerical values for the mu 0 and epsilon 0, that determines the strength of the Coulomb force and the strength of the magnetic force, and they were known numerically. And the speed of light was approximately measured at that time. He compared with this, and Maxwell was the first person in human history that this product is approximately equal to 1 over C squared. And indeed, eventually it was found to be the fact. We can make use of back-cap rule, and for the normal vectors, we can use, remember, BAC, so back-cap rule. However, if I substitute derivative operator for A and B, A, B, A, B, A, derivative operator, C, B, A, B, A, okay. Here, it's a fine. It's a fine. Here, C vector, C will be replaced with electric field. Electric field. Okay, it's not fine. It should work on any field. So we have to use this form instead of this. So derivative twice on the electric field. And then here we have this gradient must appear beforehand. So something like this. So this is what we need. So expansion of this double cross product of the gradient operator kerr becomes this. By the way, we know in the vacuum, divergence of the electric field is rho over epsilon zero, but this one vanishes, so it becomes a zero. What we have is a minus Laplacian. It is called the Laplacian. So Laplacian minus Laplacian squared. And what's that? What we have done is curl E equals a minus time derivative of magnetic field. This is Faraday's law. If I apply curl in here, what I obtain is due to this, I have minus Laplacian squared. If I apply this, we have a curl B, and then what's that? According to Maxwell's law, it is mu zero epsilon zero time derivative of electric field. As a result, what's happening is we have a double time derivative, and a double spatial derivative. If I reorganize this equation, we find this kind of form. What's that? Aha, this is, the wave equation, classical wave equation is like that. This is a wave propagating this any function of time and space. This indicates that this is a wave propagating with this speed. So what we find is mu zero epsilon zero is a constant that is 1 over c squared, and c is the speed of the electromagnetic field propagation. However, that is exactly the same as the speed of light. So any electromagnetic field is a light. So as well as visible light, infrared, ultraviolet, X-ray, gamma rays, any kind of electromagnetic wave, a radio wave, any electromagnetic wave field propagates in vacuum with the same speed that is the speed of light.